Today, we are diving into the next giant leap for wireless, a standard that was literally built for the most demanding things we can imagine. We're talking, of course, about Wi-Fi 7, or for all you network pros out there, IEEE 802.11b. And just so you know, all the information we're covering comes from a super detailed technical report on Wi-Fi and Bluetooth by the folks at RFI Detectives, who are part of Virtualization Options LLC. This is actually part 9 of a 20-part series, and today we are zeroing in on their chapter on Wi-Fi 7.
All right, let's kick things off with a quick question for you. Think about some of the most data-hungry, time-sensitive applications out there. Things like immersive cloud gaming, high-res extended reality, even mission-critical industrial automation. What's the one thing they all have in common?
Well, the answer is they push our networks to the absolute breaking point. They don't just need speed, they need extreme throughput. They need ultra-low latency to kill any lag. And here's the kicker. They need deterministic, real-time performance. That means predictable, reliable, on-time delivery of data every single time. And that's exactly where even our current Wi-Fi 6 standard really starts to struggle.
So, here's our game plan for today. We're going to start with why we even needed Wi-Fi 7 in the first place. Then, we'll look at the raw power upgrades, the seriously smart efficiency features, how it scales up the whole network, and finally, what the big payoff is for all of us. So let's start with the demand. You see, Wi-Fi 7 wasn't just some routine, incremental update. No, it was created with a very clear mission to solve some really tough problems. And the source material really just nails it with this quote. The design mandate for the IEEE 802.11be standard was, and I quote, unambiguous. And that's Wi-Fi 7. Yep, I'm saying BE at the end, not to be confused with the ancient 802.11b standard, totally different beast. The mission was crystal clear, deliver that extreme throughput and ultra-low deterministic latency. So, how in the world does Wi-Fi 7 actually pull that off? Well, the first part of the answer is pretty straightforward. A massive upgrade in raw power and speed. This is the brute force approach to performance. First up, we get much wider channels. Wi-Fi 7 officially introduces 320 MHz channel widths. Now to put that in perspective for you, that is double the maximum channel width of Wi-Fi 6E. It's like going from a 4-lane highway to an 8-lane superhighway, and it's only available in that beautiful wide-open 6 GHz band.
Okay, so alongside that much wider highway, we're also packing way more data into every single car on it. And that's where 4096 QAM comes in.
Okay, I know. Quadrature amplitude modulation sounds complicated, but think of it as the language that radio waves use to carry data. In Wi-Fi 6, we use 1024 QAM, which packed 10 bits of data into every symbol. Well, Wi-Fi 7's 4096 QAM crams 12 bits into every symbol. That's a 20% boost in data density with every single transmission. More data, same amount of time. But you know, raw power is only half the story. Where Wi-Fi 7 gets truly revolutionary, where it gets really smart, is in how it intelligently and efficiently uses the airwaves. This is all about being smarter, not just stronger. And the headline feature here is something called multi-link operation, or MLO. This is an absolute game changer. MLO lets a single device, like your laptop, connect to a Wi-Fi access point using multiple bands, say the 5 GHz and 6 GHz bands, at the exact same time. It then combines them into one single aggregated connection. It's like your data is taking 2 different superhighways at once to get to the same destination. It's a massive boost for both speed and reliability. And MLO isn't a one-size-fits-all deal. It's flexible. The gold standard is simultaneous transmit and receive, or STR, where both links are firing on all cylinders at once. But the standard also has other modes for devices where the radios might interfere with each other, or for clients like our smartphones that need to be a little more careful with battery life.
Wi-Fi 7 also gets way smarter about using the channels it has. In the past, if just a small piece of a wide channel had some interference, the whole thing was useless. Now, a feature called preamble puncturing can just puncture out that busy little section and use all the clean parts around it. And where Wi-Fi 6 assigned one block of resources to a device, Wi-Fi 7 can assign multiple resource units, giving it incredible flexibility. The bottom line here, no more wasted spectrum.
Okay, so we've got more power, and we've got more intelligence. The final piece of this puzzle is scale. So let's take a look at how Wi-Fi 7 expands the total capacity of the entire wireless network fabric.
And the answer really starts with this number, 16.
Wi-Fi 7 doubles the maximum number of spatial streams from 8 in Wi-Fi 6 all the way up to a massive 16. Let that sink in. This is a direct doubling of the network's total capacity.
Now, I know what you're probably thinking. My phone doesn't have 16 antennas, and you are absolutely right. No single client device is going to have that many. This is where a brilliant feature called multi-AP coordination comes into play. It lets multiple access points team up, coordinating their transmissions to act like one giant distributed virtual antenna array. This is how the network can actually use all 16 of those streams to serve tons of clients over a really big area.
Okay, we have covered a lot of technical ground, so let's pull it all together and look at the bottom line. What is the real-world payoff of all these incredible advancements?
I mean, this table just says it all. When you put Wi-Fi 6 and Wi-Fi 7 side by side, it's not even close. Wi-Fi 7 doubles the channel width. It boosts the data density with 4096 QAM. It doubles the spatial streams, and it moves way beyond simple band steering to true multi-link operation. This is a massive generational leap across every single key metric. And the result of all these upgrades, the whole reason for this entire standard, brings us right back to the beginning. Every single feature, the wider channels, the smarter links, the greater scale, it all serves that one unambiguous mandate: to deliver extreme throughput and ultra-low deterministic latency.
So, I'll leave you with this one final, really exciting question. For years, our most ambitious ideas have been held back by the network. But now that the network can finally keep up with our imagination, what are we going to invent next?